trying to put some order, and he's going to share that today. So, Andrew, could you come, please, and share your presentation with us? And if you have any other thing that you want to add, where you graduated, I mean, those things we have it in our portal. So I decided in terms of time to minimize that. But if you have anything that you might want to share, go ahead.
Okay.
You can use these to pass the slides and to point to your slides. Thank you.
Yeah. Thank you, Osvaldo. Let's give Osvaldo a round of applause for his presentation earlier there. Thanks.
Thank you.
Okay. As Osvaldo said, my name is Andrew Cooper. I'm the energy specialist at NewGold's New Afton mine up in British Columbia, way up north in Canada. Our vision at NewGold is to make energy management self-sustaining, something that's done on a day-to-day basis as part of what we do at NewGold, so that everybody does it as part of their job, and that's how we proceed in the organization. Now, Steve and I are the only people between you and your break. So we're going to be quick and as informative, because I'm sure you need a caffeine injection after your lunch is digesting. Just a bit about NewGold. NewGold is an intermediate mining company. We have 4 producing assets at the moment and 2 significant development projects. Due to efficient production and very, very specialized mining methods, NewGold is one of the lowest cost producers in the industry. And we're hoping that with our good energy management practices that we can reduce those costs even further. Andrew was telling me about the heater up there. I've got a suggestion for the Hilton Hotel for an efficiency project. When we change these to LEDs, and it won't be so hot up here. Just a little bit about my background. You can tell from my accent that I'm not from this part of the world. So I'm from a little town called Bulawayo in Zimbabwe. That little red dot there, the sort of south tip of Africa. Now, in Bulawayo, water was a pretty scarce resource. And we were subject at times to very, very strict water rationing. And sometimes in the months just before the annual rains, it would really get so hot and it would really get so dry that sometimes it would get so hot and dry that when the traffic lights turned green, the goats would even try and eat them. But so it was because of, I believe, this situation that I found a passion for minimizing waste and maximizing the use of the resources that are available to us. But it wasn't until I started working first as an electrical engineer and then as an engineering manager at this place, which is Sifto Salt Mine in Goldridge, Ontario, purportedly the world's largest underground salt mine, that I really started to get an idea of the impact of the financial impact of efficiency improvement projects. What we found is that to date we have what I call the roller coaster approach to energy management, or the project-based approach. What happens is you get a consultant comes around, a supplier, work groups, departments. They come around and say, let's do an energy audit. So they go and they look around and they find out this cliched word, let's look for the low-hanging fruit. So they come and they say, oh, there's some lighting, here's a compressed air project, oh, there's a pumping system project. And they focus on the financial benefits of the energy efficiency improvement upgrade on those areas. Then what happens is they create some wonderful anticipation around the return on investment we're going to get from this efficiency improvement projects. They implement the project, and then hopefully they get everybody excited about the financial benefits of this. Excellent. But what happens over time is we find that components wear, leaks develop, your new pump or motor is replaced with a bigger model because, hey, there wasn't a spare for the one we just fixed, and you find that your savings over time start to drop off again. Then someone comes in and says, let's do an energy audit again. And so the whole cycle runs around again. This is not continual improvement, and this is not sustainable energy management. What do we want? There's a well-known politician whose solution to reducing the effect of global warming was to change from Fahrenheit to Celsius. So we're hoping what we want to do is more efficient than that. We are focused on long-term sustainable energy management, continual improvement, where energy management is developed into the systems organization, so it's done by everybody on a day-to-day basis, a part of what they do, at the organization. And it's because of this that when the ISO 50001 was launched in June 2011, has anybody here taken on the implementation of ISO 50001? Excellent. And who's heard of it? Okay, there's a few more. Okay. Well, I was exceptionally excited when I saw the system coming into play, because I saw this as a vehicle to achieve our vision. Why? Because one, it focused on the usual PDAC cycle, Plan, Do, Check, Act of continual improvement. And secondly, because it developed and built energy management into the culture and systems of an organization. So we decided to take on the challenge, and we decided we were going to be ISO 50001 compliant by December 2013. And that is actually something that we are actually on track to achieve. When reading through the ISO 50001 standard, we came to realize that an energy management information system was absolutely essential for the success of ISO 50001. First of all, from focusing on measurement of your energy objectives and targets, for monitoring, measurement, analysis of your energy in the plant, and also for being able to pick up significant deviations from target baselines. So we decided then to focus on the energy management system, but we needed some help. And the first bit of help I found was this manual here. It's the Natural Resources Canada Energy Management Information System Planning Manual and Tool. It's a hell of a mouthful, but it's available free of charge on the Natural Resources Canada website. So if you're thinking of starting an energy management information system, that is one of the best resources books you can actually look at. It's an excellent tool, and it got us started in the right direction. After doing an audit of our existing energy management system, which didn't take long because we didn't have one, we then had to go by setting up these, what we call the energy account centers. So the ones we set up, we focused on the areas of our mill which aligned with our cost accounting, mill processing, surface facilities, mining, and then crushing and conveying. And then we broke those down further into sub-energy account centers. So we focused on mill processing, for example, down into components of grinding, flotation, regrind, tailings. And we had to then link up all energy sources, which we've got electricity, propane, natural gas, diesel and explosives, and tie those all into those existing energy account centers. Sub-metering, oh my goodness. I had literally started planning for this months and months in advance. I had no idea of the complexity of this and the amount of work it would take to get the information from sub-meters into the PI system. Fortunately, Martin Leverage, who I'll speak a little bit about a little bit later on, came up with this data concentrator idea. Basically an Allen Bradley Compact Logics PLC with a Modbus, ProSoft Modbus card, and this went out and pulled all the data and brought it back into the data concentrator, processes it, and made it available to be handed off to the PI system. Triactor meters. I was invited to view an energy management system for a data center up in Kamloops, British Columbia. I was a little bit skeptical because they were only very, very small and we were very, very big, so I almost didn't go. But when we got there, I found these triactor meters here. And I found that using these triactor meters, we could tie the feeds, 12 feeds from one MCC into one triactor meter, as opposed to putting in 12 individual meters. This was an aha moment for me, really, and it really transformed the way I actually viewed the sub-metering. It made it a reality, and it dramatically reduced our costs. So that was a reminder to me to really just get a wake-up and keep an open mind. At the end of the day, we ended up with 147 electrical sub-meters. We had 81 that were brand new. We had 66 existing meters, but they hadn't been configured at all to measure any energy whatsoever. And we had all those tied into the data concentrator. We also then had installed 4 new gas meters and 2 pulse handoffs from the incoming gas supply. Now, I'm an electrical guy, and I've never had to deal with the frustration of the gas laws. So things like pressure compensation and really threw me for a six, and it took me ages to figure out and get that right. So this is something to be aware of. The last energy sources, diesel, explosives, propane, we set up a system to manually enter that until that data capture could be automated. Now we needed some software. So the specifications that I put out there was that I committed to the people who were doing the installation for us that all information would be available in the PI system. I figured that it was a hell of a job getting it in there, and it would cost a fortune for someone else to do it. So all data available in the PI system, it would support ISO 50001. It would meet the EMIS criteria laid out in the Natural Resources Canada Planning Manual and Tool, and it had to be done in 3 months. It wasn't a very big ask, but we went out, and I got some referrals from Dean Henley from OSI in Canada, and we went out for 7 proposals. We got 5 bidders. One proposal really stood out and was viewed favorably by the entire review panel. The Real-Time Energy Management Information System by RT Tech Software was proposed by ADM Systems Engineering. Why did it stand out? First of all, they had good experience in an industrial environment. I went out there, I've seen so many energy management systems which are focused on buildings, facilities, and there was a big shortage of energy management on an industrial environment. They had that experience, they had done it. They worked off the PI system backbone. The references, and yes, I actually did find the references, and they were very happy with the existing systems, and some were actually planning to install more at other facilities. And importantly, they were able to meet the timelines. In fact, RT Tech Software is one of the sponsors of this conference, and RT Tech Software, as well as ADM System Engineering, are part of the exhibition outside there. So I really encourage you to take a look at this, and I promise this is not a paid commercial either. These guys have done a great job for us. This fast-track project, I feel, was a little bit like parachuting. We started off in May 2012 planning, and everything was nice. We had lots of time, and we floated down, and all was well and good. Even when we started sub-metering in August, it was still good. But then I got the proposal request, and the capital was approved in September, and the ground rush started. From RFP on the 1st of April to the implementation in December, the whole thing was an absolute blur. There were 2 people without which this would not be possible. The first one is G1. I call him G1 because he's Guru 1. This is Martin Loveridge out of Ingersoll, Ontario, a company called Indal Control Services. Martin is one of the smartest guys I know. His intuition and ability to get things done has really been fantastic. I've worked with Martin for many, many years, and if it wasn't for him, I would be in deep, deep, deep trouble. The other person, and this is not John Malkovich, this is Steve Boyka. There's Guru 2. Steve is from ADM System Engineering. His cool, calm, and collected and seemingly unfazed approach and his deep, deep knowledge of the PI system really transformed mountains into little speed bumps. Steve has been with ADM System Engineering for about 4 years now. He calls himself an army brat, but he still managed to live in New Brunswick for about 27 years before moving to Winnipeg about 4 years ago. I'd like to believe that was for the job, not the weather, Steve. His passion is photography, especially taking photographs of trains, and I've seen some of his work, and it's awesome. He's been working with the PI system now for about 15 years as a systems integrator, a developer, and a systems manager in the mining, the food and beverage, and the power industry. He's a really, really smart guy. He really knows his stuff. So please help me welcome to the stage the cool, calm, and collected Steve Boyka. There you go, Steve.
Thank you. Well, I might be blushing a little bit. Thank you very much. Thanks for coming to see our talk here. I presented back at year 2000, after surviving the year 2000 debacle, or non-event. I presented here at the OSI conference on what we were doing in my previous job in the power industry, including the magical world of putting data on smartphones, as we called them then, or as we call them now, dumb phones because they're a little more advanced. So happy to be here. We're a system integrator. As Andrew said, I've been with ADM for about 4 years and based in sunny and warm Winnipeg, and I do work all over North America and remotely all over the world with Pi integration. So when I first came to NewGold in November, I believe it was, of last year, to survey what they had, what I found was that they had a really good infrastructure, and that was really important to the project's success. They already had a Pi server. It's up and running. It was new. All the infrastructure at NewGold was new, so that was good. They had an OPC interface for the DCS already up and running. They have a good Pi administrator there who knows his stuff, which is very helpful as well. Most of the users there use CoreSite, so they're very happy with CoreSite and how it works. The power users, the metallurgists, they use ProcessBook and DataLink for deeper analysis. So it was nice to have a good infrastructure there. Now, what this project brought to NewGold was, as Andrew mentioned, the metering network and the data concentrator PLC. So what that is a network that basically stretches all over the surface and below ground, bringing the data from all these meters back to a data concentrator PLC. So the concept that Martin had was to basically bring all these meters into one place, do whatever massaging of the data needed to be done to bring it to the right units and the right summation, and then to make it available through an OPC server to Pi, who would then record it. What we also brought to the table was we had an application server that was built for RTEMIS and a SQL server for RTEMIS data. So RTEMIS to the user as a web interface. There's an interface for the configuration of the product, as well as an interface for reporting. I'm going to talk a little bit about what RTEMIS is. Basically, it is a system built on top of Pi that allows you to analyze what energy you're using in your enterprise and determine what your cost of energy is in each area, and relate it to the cost of production, so that you can get some good KPIs out of it in terms of what your energy cost is per ton of product, per pound of per volume of whatever you're producing. As Andrew said, we're in the industrial space, not really in the commercial space. So we work our customers with RTEMIS from RT Tech is our industrial users, large industrial users. So RTEMIS is structured to match your enterprise. Andrew showed his EACs, his energy account centers. What they show is he's mapping his enterprise into areas that make sense to him, to the business, so that when you can look at it and you say, okay, my mining area, my surface, my mill, so on, all these things make sense to the business, and you can see the cost by them. RTEMIS will allow you to go to report down on the energy account level. So if you want to get detail on each area, on what it's costing you in terms of energy, you can, and then it'll roll it all up to the top, so you can have a big picture view of your entire site or your enterprise to see what your energy costs are for the whole area, how it's divided among the different types of energy you consume, and then take action upon it. So RTEMIS, as I said, is based on Pi. It gets its data from Pi, and then it brings it in the calculation engine to do the calculations, all the roll-ups, and store it back in Pi. There's a configuration toolkit to maintain it. There's an energy target calculator, which is used to look at your historical data and build you a realistic target that you can use going forward to measure your performance against. As I said, the user interface is for user input to it and reporting back to the user. And can interface with other systems, your ERP and your maintenance systems, through an XML interface. A couple of sample reports from New Afton. Excuse me. The one on the left shows their target versus actual and their grinding over a period of time. This is all data that's stored in Pi and reported with RTEMIS, and versus production. And at the bottom you can see they have a Q sum, which is basically over the reporting period how much you're either saving or losing money based on how you're performing against your target. So you can use these Q sums to get a quick picture view of how you're doing against the targets you've set. On the right, there's a cost report, which shows you breakdown by area of what it's costing you to operate based on the different energy types. These energy types are configurable, and these are the energy types that are in use at New Afton. And then the pie chart shows you how it's broken down by energy type. At New Afton, the electricity and the gas are automatically obtained through these interfaces through the DCS or the data concentrator and entered into Pi. And at present, the rest of them are manually entered. And hopefully over time, we plan on making some of those automatically entered to reduce the manual entry. Just a quick screenshot of the configuration toolkit. This just shows you how you can maintain the system. Over here is your energy asset tree. This is not NewGold. This is another customer. The asset tree, and then you go to each level, and you can define what energy types are appropriate at each level. It may be that some of the EACs only use electricity, some may use electricity, natural gas, and so forth. So that's configurable at each energy account center. And then for that, you have a rate of consumption, a target for that rate, and the price of the energy. We had a few challenges with this project. One I didn't list, of course, is the timeline. As Andrew said, it was a pretty fast-track project. That's good. What virtual meter definition? In RTEMIS, we have the concept of a virtual meter being a combination of real inputs into a virtual meter. So in some areas, you may have multiple meters that they want to sum together, or in some cases, like at NewGold, you may have one large meter that covers several areas. So you have to take the large meter and subtract a bunch of meters to what's left over is the consumption for that area. So now that's one of the challenges to get that set up. As Andrew mentioned, the gas meter scaling was a bit of a challenge. Data quality is always an issue, and we had some hiccups in the data concentrator in terms of meter resets, because we're accumulating basically kilowatt hours over a period, and whenever we would reload the PLC, the kilowatt hours would dip briefly to zero and then back up again, and RTEMIS interpreted that as basically the counter resetting, so there was a big jump in consumption. So that's been fixed. A few of the next steps we have with RTEMIS. There's a new version of RTEMIS out, so we're going to upgrade NewGold to that. We'll be implementing their target calculator there to help Andrew determine what his target should be on each of the energy account centers. And we hope we plan to replace some of the manual inputs with automated data feeds. For example, diesel consumption, they have a mining management system that they're implementing right now, and what they will be doing with that, it will be tracking all the movements underground of material, and also of every time they fuel the trucks up, they're going to be recording that. So we're going to take all that data and bring it to Pi to give a moderately real-time view of diesel consumption. Right now, what they have is a monthly number. They use so many thousands of liters of diesel per month, and then we have to back calculate it to put it back into Pi, and it's not very accurate in terms of it has no relation really to production except over the month. So if we can get a moderately real-time view of consumption, we can have a better relation of production versus consumption. As well, there's there's a above ground fueling facility that we're going to integrate with Pi. So every time a truck above ground comes and fuels up, we'll record that in Pi as well. So improvements like that will help. All right, I'll hand it back to Andrew.
Thanks, Steve. So what are the benefits of the system thus far? Well, it's early days yet, but we have had some tangible benefits thus far. We've managed to establish energy baselines for some of our energy account centers and some of our significant energy users in terms of ISO. Looking at the grinding energy intensity, our pebble crusher was down for a short period of time, and using the information from the EMIS, we found out that we were using 17% more energy for per ton of mill feed when the pebble crusher was down as opposed to when it was running. And that was just a discovery as a result of the EMIS. Energy cost allocation every month has become a lot easier and far more accurate. And the energy studies, even though not directly out of the RT-EMIS system, the data is in Pi as a result of this project. And this has helped us with the data gathering and made it a lot easier. But the intangible benefits are where I feel the big bang for the buck has been. NewGold has received great PR as a result of this, not only because of the RT-EMIS, but also because of ISO 5001. We are the first mine in Canada to be undertaking ISO 5001 implementation, and this has created a lot of excellent PR. And then awareness around energy management in general has increased because of the existence of the RT-EMIS. Lessons learned, more complex than I imagined. I don't know, I think I mentioned that before. But the sub-metering was a real challenge and really needs to be thought about long and hard because that can really extend the project out. No matter how important you think your EMIS is, production still trumps installation. So there are times when I had to sit back, shut up, and bide my time just to get something installed. If you're doing something new, include energy management and energy sub-metering in the specifications. It will save you a lot of time and a lot of money down the line. And even if you don't go for a full-blown energy management information system, utilize a historian database like the Pi system for capturing the data. Once you've got it there, there's so much you can do with it, and it makes life a lot easier. So what are the objectives going forward? First of all, we still need to carry on building ISO 50001 around the RT-EMIS system so that we can realize the benefits of both systems. Budgeting and forecasting, I'm really looking forward to doing the budgeting forecasting for 2014 based on the prediction models from the RT-EMIS. And then, lastly and most importantly, I think, is proof of concept. There's been very difficult over the past to justify the amount of money you need for a full-blown energy management information system. And it's just as difficult for utilities to give you funding for that type of project because really there is no concrete proof yet of savings as a result of an energy management information system. I've had a lot of eyes on me because of my excited promises, and I have a goal that by the end of 2014 we are going to prove that we are achieving the 5 to 8% reduction in energy costs that I committed to when I applied for money for this project. And that will give us a payback of a little bit under a year, which is very exciting and is yet to be proved. So, our vision at NewGold is to make continual energy performance self-sustaining, something that is done by all employees on a day-to-day basis as part of what we do at NewGold. So, thank you for your time.
Any questions for Andrew or our friend here? You have some wrap-ups or questions for him? I mean,
well, maybe before we break, I think thank you for your talk. Very good talk. Very appreciate your enthusiasm. Just a couple of things I want to focus on before we go to break. I think we've all heard the term low-hanging fruit and energy management used ad nauseum in many conferences throughout the world. It's used all the time. I think what Steve and Andrew have pointed out, though, is that there's a fundamental weakness in that approach, and that you begin to degrade the energy efficiency that ultimately happens. Instead, perhaps, if you take a much more a different approach by really trying to benchmark and understand your processes in a much more fundamental and systemic way, you have a much better chance of focusing your resources and scarce investment dollars in those things that will not only pay off for the long term, but or pay off in large amounts, but also over the long term. And you'll find a much more systemic way of directing your energy, your investments in energy towards the biggest payoff long term. I'm hoping that ISO 50001 is something that a number of organizations would look at, and perhaps you're blazing a trail, and maybe next year you might have another paper, maybe for the UC, to talk about the progress that you've made in 50001. And I think it's probably something everybody here, if they're not thinking about it now, they probably will, because I think it's growing definitely in popularity. So why don't I leave it there, and we can take a short break, and we will come back when, Alice?
Yeah, let's do 3 so we can
3
finish
o'clock.
around 4.
Great.
And I have a present for him. He's been the pizza cutter, because you are really improving him, and he has a redundancy.
It's a pie cutter. It's a pie cutter
It's
shaped
a pie
as
cutter.
pie.
Thanks,
So,
Walter.
great. Thanks a lot.
Thanks.
Thank you very much. All right.
Thank you.
Great.